the recording. I always wanted to check for how the recording works here on the tool. So we wanted to talk about data normalization as we do it in databases. So I usually start this session with the question, what is a database? I'm going to answer that one myself. So a database is a structured place to store data. Yeah, so it's a structured, usually a service where you can put your data in a structured way. Yeah. So what kind of databases do you know, or did you already have worked with?
Relational database.
That's one form. Yeah, and the other one that's used widely in the last years.
NoSQL.
Yeah, the NoSQL. Mostly they're document stored. So the structure in MongoDB and others, CouchDB and so on, is document based. Yeah. So you have usually a JSON structure that you put in there with your data. And there is the relational database. So we're going to talk mainly about relational databases today, because this is where the normalization process stems from. So what is happening when we're storing, or what is the main structure we have in a relational database? Well, that's simple. We store it in
ID.
tables. Yeah, we
Yeah.
store it in tables.
Type.
So as opposed to document-based, like JSON documents, we're storing it here in tables. And the tables obviously have columns and rows. So the rows are basically the sets of data, and the columns are, let's say, the attributes. Yeah, what makes this data. So we've all seen that. Everybody who ever used Excel saw a structure like that. And basically, a relational database is nothing more than a fancy Excel. So I know that there is a lot of guys out there who are developing stuff like relational databases that they want to kick me now. But in the end, for a beginner, you can really envision a relational database like a bunch of tables in an Excel file. Yeah. So yeah, it's not more than that. So we have the columns, we have the rows, and this is what is called a relation. So every row has its column related to it. So each column describes something in that row. So that's what we call a relation. In some papers, in some books, you will also find the expression relation instead of table. They are talking of relations when they're talking of tables. Yeah, so just to know where the relation from relational databases comes from. Okay, so
Yeah.
that is the first thing. So we have to take care of. We're talking of tables or of data sets with attributes in there. So now if we want to store some data in a table, yeah, we usually have to structure it in some way. So I'm going to tell you guys, I know that I need to store my person data somewhere in a relational database. So how are you going to organize the table? What is being done here? So what's the first thing you would want to know? If I tell you, come on guys, we do a project, I want to store person data. What would
Personal data.
Yeah, persons. I want to store all our customers in a relational database. So what would the first questions of you be?
What attributes that person has?
For example,
Yes.
so I say I need to know if they're male, female, or something else. Yeah. What first name they have, what last name they have, what addresses they have. So this is what I want to store. Okay.
And there are different groups.
Sorry.
I said there are different groups. If there is.
What are different groups?
I mean the different groups of the customers, if there is.
So
Yeah. For instance,
I'm your project manager here. I tell you what we store. Yeah, but something like different groups will definitely come in later. So we have like the big customers, the smaller customers. Well, later we might want to store invoices for those customers, the different email addresses, telephone numbers, stuff like that. So the first thing you need to do is to clarify what data we're talking about. Yeah, that's what you just did. So what attributes? Yeah, what is it you want to store? And you usually try to acquire some example data sets. Yeah. So and with that you're starting to build a table. And the way you build the table is for example, addressed by what the customer deems a unit of a person. So what is a person to you? And usually if you really design your databases for a project, for a client, you need to do a lot of talking first. You need to understand what the object the client wants to store in the database, what this object is about. Yeah. You really need to
mm,
understand, because when we're talking about normalization in a moment, this is always depending on how the use case, how the project, how the client sees these attributes. There is not a single way to always divide up the data, because that's what normalization usually is. Yeah, it is something that we really, really need to understand for this project, for this client. So normally it starts all with a lot of questioning the client. What does he want to do with it? How does he understand what's the gender for him? Yeah. What does he need it for? Yeah. Does he just will he just use it in the address field where he says dear sir, dear lady, or is there something else he wants to do with it? Yeah. Is the address that he's using, is that to print it out on an envelope, or is it to sort or get a certain zip code and all customers that belong to that zip code, or to a certain city and all customers that belong to the city or a country or a region? So because these are different use cases for the same kind of data, and you really need to understand what the client, what the project needs for that. So usually there's a usual way of splitting up the data that you're getting and how you're storing it in your database. And most of the time we assume we know what the client says or what the project needs. When I say I need person data stored, yeah, then this is pretty clear to everybody of us, but it might not be the same view we have in between here, or even with the client. So the main point I want to make here is you need to understand what the client does with the data to determine how we split it up. And now we're talking about normalization. This is if the client tells you, this is the data I want to store for a person, for example. Person is a nice example here. This is the data I want to store. Then he usually can tell you these are like first name, last name. I need a middle name. I once did an address database where it was very, very important to have all like titles in there, and also not academic titles only, but also like the duke of something, or a prince of so and so, yeah, because they were benefactors of some institution. So they donated money, and when someone gives you a lot of money, like 100,000 euros, you really want to make
mm,
sure you address him correctly. So is the professor doctor in front of the prince, or is the prince in front of the professor doctor, and there's titles that are at the end of the name? So this is different from your usual Mr. Mrs. Yeah, or Mr. Miss, first name, last name. Yeah. So this is why you really, really, really need to address the subject, the object, the data we're talking about. Is that clear so far? Yeah. So anytime we get data and we are creating database from bottom up, fresh, we need to really understand, thoroughly understand what the client is using, what's the use case, what the client is using this data for. Okay? So let's go dig deeper into that person data thing. I'm the client, and of you, you are my developers, and I tell you, I want to store all our customers in that database, and I want to be able to do all sorts of stuff there. Yeah. So your question would be, again,
what exactly do you want to use it to do?
exactly, and what is the data you want to store, and what do you want to use it for? So I say, I want the clients so that I can track which of my salespersons sold how much to each client. Ta-da! And there you got it. So what does this data tell you? Does this phrase tell you what I just said? I want to see our client and want to know which salesperson sold how many euros per year to which client. That's the main focus of my application I want to have.
We need two tables at least, one with persons and one with transactions.
Yeah,
and they have a
something like
relation
that.
between
So,
them.
yeah, Alex?
No, I was just holding the
Okay.
hand.
No, so basically what Willie said is completely right. I wouldn't phrase it like we need like several tables. You might think that in your head, but basically we're talking about at least three different objects already here.
Yes.
We have the clients,
Sales.
we have the sales, both are persons, yeah, but there are different kinds of persons, yeah, and they might have different attributes.
And
Then
goods.
we have some kind of linkage between the salesperson and the client, obviously. And we have somehow the number that this client bought from this salesperson. Okay? So then your next question. So this is what you should have in mind. We have like salesperson, we have client as a person, or maybe as a company. Maybe clients is company. Yeah. So we have salespersons. Sales are definitely persons, and we have like this what they sold to them.
Yeah.
And
the
then
goods.
yeah, so yeah, goods or services or whatever. And then I say, yeah, sure, this is what we need there. Didn't I tell you? Yeah, I want the clients in there, and I want to be able to filter. Also, I want to see which product group they consumed most. Did they consume more goods or more services from us? So now it's getting even more complicated. Yeah, because now we have like a product group at least, and most likely we have products underneath. You're all following me? Yeah? Any questions on that? I think a real world example like that is
Okay.
yeah, okay, is always nice. So now we can start to sift a little. So if that is after like talking to your obviously very IT savvy client, me in that case, who says he wants a client search database and obviously needs a lot more than that. Yeah. You're now able to dig a little bit deeper. So usually this goes on for an hour or two, this kind of talk. What do you really want to do? Did you think about that? And what is that? Do you know where you want to go? How many users are going to use that thing? How big is your client data at the moment? How many clients do you have? How many salespeople do you have? Are the salespeople in groups by region? But maybe they have a manager and you want to group it by manager, yeah, because he says he wants to see how many a salesperson sells, but maybe he has a structured, a hierarchical sales field, yeah, where he wants to see the aggregation. So I'm a sales team leader, and I want to see what each of my sales guys is selling, but my boss also wants to see what all the team leaders are selling. So all these questions would arise and should be tackled and should be noted down. And then in the end, you have a clear view or a clearer view. Usually you don't get all the info in the first setting. Yeah. But then you have a clearer view on what the client wants, and you're digging into what is exactly the attributes you're having. Yeah. And so then you usually get like an Excel sheet, yeah, with an excerpt of, with an extract of some part of some tool he's already having, or he's just jotted down in Excel. So if it's a startup, it might also be that you just get the raw Excel file where they store all their stuff, yeah. And then you have their like of the sales people, because you requested it. He wouldn't have given you the sales list in the first place. Yeah, that was obvious that you had to know that. Yeah, without even asking crystal ball, stuff like that. So then you would get like the data of an Excel sheet for the sales guys, where you see first name, last name, mobile number, sales ID, yeah, so stuff like that. Then you would get a list of clients, and these are mixed, like persons and companies with persons that they are the contact point of that company. So it's a pretty mixed experience here, yeah. And then you would have like the products, yeah, a list of products that they're selling with the product group ID, and maybe a fourth table where the product group is already with the description and another title and another IDs there. So this is what you get. And now we're into digging into normalizing stuff, because this is the raw data you're getting from your client. And the next step then would be to see how we can structure this data so that it fits into our database without having any what we call insert or update or delete anomalies. So the insert, update, delete anomalies are anomalies you have if your data is badly structured in the database. You're getting like corrupt data relations by inserting, by updating, or by deleting. Yeah. So for a moment, let's rest this example of the sales guy that wants to know who sells how much. I had a nice example in another database I worked on that was for a private law school, yeah, where we did the management system of the law school. And there were seminars and there were professors who gave that seminar. So two tables, okay? One with professor names and one with seminars. And there shouldn't be a seminar without a professor who just does that seminar. So, and if it's badly done, yeah, you can either not have a professor in there without also having a seminar. So if you have one big table where it's like professor, seminar 1, seminar 2, seminar 3 in one table, yeah, and it's the professor's name and it's the seminar's title and the second seminar's title. So if you then delete a seminar, you're deleting the professor too, yeah. Understood? So this is what we call a delete anomaly. I cannot delete one without the other. Yeah, sure, I can update instead of, I know, but basically this is bad database design. I should be able to delete a row, yeah, without having corrupt data somewhere else. Or I should be able to insert something, insert a single object without that affecting anything else. And I should be able, so for example, if I do the same badly structured thing, maybe I have professor and seminar, professor and seminar, professor and seminar, and I have like one professor does 3 seminars, yeah, and another does 5, so he's 5 times in that table, yeah. And then this professor is a woman or a man who marries and changes her or his name because of that marriage. What is done there? You update it on one seminar, but you forget it on the other. Yeah, that's what we call an update anomaly. Yeah. So this is something you want to avoid by correctly structuring your data. And this correctly structuring your data is what we call normalization. To say it like I see it in the wild, most of the time you don't find correctly normalized data. Most of the time you still have some bad references inside. What this is, we will dig a little bit more into, okay? So what we call
Okay.
the first normal form. So there is normalization is structured in normal forms, and these forms build on top, or I should do it from bottom up, build on top of the other. So it's the first normal form. And then if you want to have the second normal form, you have to fulfill everything from the first normal form, and then you apply the second normal form. If you have the second normal form, you want to apply the third normal form, you have to do the steps of the first two before. Then there is a normal form we call 3.5 or Boyce-Codd normal form, which builds on the third. So you cannot do the Boyce-Codd without doing the others. So, okay, and the first normal form is
I didn't
basically,
get you.
okay, this is if you get the data like I just told you, like we're back in the sales example, yeah, customer sales example. And I give you this data, maybe even not in an Excel, but in a Word document. I give you a Word document with all the data written in there. Then you need to start structure it that you can put it into tables. And this kind of work of structuring the data so that you can put it into tables is called normalization. And the first normal form means that you're looking at the data and you're identifying different same attributes, like first name. This is a first name, and that's a first name. So I think we have an attribute here called first name on that person. Yeah, might be that in some cases there is no first name because it's not important. Yeah, for the database we're looking at, or for the project we're looking at. So I need to identify what kind of data do I have, and I group it into the different columns, into the different attributes. Okay, and
Okay.
that is what we call the first normal form, from raw unstructured data to grouping stuff into similar data types of columns of attributes in the first place. That's the first normal form. Okay.
Mhm.
So basically, this is the most basic thing you need to do to have a table. Before, we just had some sluggish raw data, and now we're getting into the first normal form by having really columns, something like columns, something like yeah, something like similar stuff. Yeah. So like first names, last names, maybe
Mm.
address. Yeah. First name, last name, address, and gender, Mr., Miss, whatever. Yeah. So we had just a law passed in Germany. I don't know, or in Europe, where it's not only two genders anymore. We need to have a third one for people that are not determinable, genetically determinable male or female. There is obviously such people, and somebody put through that it's not only male, female, we need to have a third one for mixed types. So, yeah, but I'm deviating a bit. So we have, like we saw, we have a gender, we have a first name, we have a last name, we have an address. So grouping it into these kind of fields, similar fields, this is what we call the first normal form. You can find a little bit of a description of that in the links I put into the meeting. Yeah. So the first link is a very, very raw description of the different normalization forms. So the first thing is I'm seeing the data structured. I'm identifying already same attributes. Yeah. So like first name, last name, I'm identifying addresses, I'm identifying IDs, yeah, so customer IDs, sales IDs, product group IDs. So if there is something like that, I need to identify that in the data, and I need to think of, okay, maybe I'll do a product table. Yeah, most likely I'll do a product table, and there is product name, product ID, product whatever, product group name, product group ID, all that goes into that table first. Yeah. And then I need to like see, okay, person goes into one relation, products go into another relation or table. So this is what we call the first a normal form. The way I learned it, it's just structuring into columns. It's not even you. Most of the time, you don't even need to think about what table you need at the moment. It's just similar data into columns out of the garbage you're seeing. You're seeing a heap of spaghetti, and now you're like ordering the spaghetti by size or color or whatever. So that's what we call the first normal form. So then, after we have identified this, we go to the second normal form. And this can only be done after we already identified we have different groups, we have different attributes. And that was the point, Samuel, I was building on. So the first normal form is identifying the attributes you see. You obviously see from the data the client is giving you. And the second normal form is usually where you get to more tables. Maybe you have in the beginning one big table where you just have different columns, and now you're identifying that you might need different columns, different tables, sorry. Yeah. Usually by normalizing data more and more, the higher the normal form gets, the more tables we have in our database. That's pretty sure. So the better normalized or the more normalized a data set is, a project is, the more tables you see in the database. But I've seen projects that were not normalized at all and had 500 tables in there. So this is not always, you cannot, it doesn't go the other way around. Yeah. By normalizing data, getting a better data structure in there, you get more tables. But just because you see a lot of tables, that doesn't mean the data is well normalized. Yeah. Okay. Good. So first normal form, second normal form. Second normal form is that you identify a primary key, what we call a primary key. So what is a primary key? A primary key is for a group of attributes, one attribute by which I can identify each set. So in the customer case, the primary key usually would be the customer ID. Yeah, because in all systems I know, I have one identifier, one number for each customer, because I want to know to exactly identify that. In our case, in Dun & Bradstreet and Bisnode, we have the DUNS number as the identifier for a company, so that I can really like uniquely say this DUNS number belongs to that set of attributes. Okay? So second normal form, I identify within this structured, now more structured data, primary keys, attributes where all other attributes relate to. Yeah? Yes, Willie?
But it also has to be unique.
Yeah, if it doesn't make any sense if the identifier is not unique. So in some cases, it can be, it's not only one column. So usually it's one column, it's one attribute is the identifier. But it could be, let's talk about the product table that I talked about before, okay? So it could be that a product is determined by another attribute. So it has an ID 1, 2, 3, 4, 5, but it might have like a region where it's sold. So I have 5 products I sell in Europe and 5 products I sell in the USA. And the first product there has the number 1, the second the number 2, yeah, or we do it with letters A, B, C, D, E. And I have other products, A, B, C, D, E, that I sell in the US. So I can identify that A, B, C, D, E together with the country is the identifier for that product. So we have two attributes that together identify a special product. Yeah. I think this is not a good way of doing it, but you might find that in some project. Yeah. So first we go to the basis, we group stuff into columns. If we see obviously this is not belonging together, we are splitting it up in tables. Second step, we identify what we call the primary key. Yeah. So the attribute or the attributes that identify the complete row in a table. So if I have this attribute or these attributes, I definitely know I can have only this set of data and none else. Okay? That's what we call a primary key. So it's social security number for people very often. Yeah. It's yeah, maybe a company name together with an address. If I don't have a DUNS number, yeah, in our case we have a DUNS number, so we have an identifier, a numeric, unique. For products, it might be a product code, yeah, or something else. For addresses, what could be an identifier for addresses? What separates one address? Yeah, what separates one address from the other? So I have, for example, salespeople. Okay, I have salespeople. They have first name, last name, gender, and they have an address with a zip code, city, street, and street number. Yeah. So yes,
I guess street number.
street number is 30.
His street number can actually be in two different places.
Yeah.
If you say zip code, two people can have the same zip code.
Exactly. Yeah, but we're now into normalization step 2. Yeah, normal form, second normal form, we identify primary keys. So for now, we can stay with what I just said. We keep the address parts as attributes of the sales ID. So let's say I have each sales guy, each member in the sales team has a person ID of the company. So everybody who gets into the company gets a number, and this number is then their identifier, and all attributes are attached to that identifier and the address too. Let's just mix the address in here too, for now. I was smiling a bit because I had a client like 10 years ago who was always talking to his employees. He was the boss and he was not a manager, he was a boss. So he ran around with a whip and was shouting at people and so on. And he always addressed them by numbers. Hey, number 3, you got to do this and that. And that was the number they got when they came into your company. So number 105 has to do this. And then you came in as an external and you were, what? Who had to do what? Yeah, 105, that's her. So, and he was talking to people like that. Yeah, 79, you have to do this. Yeah, not a place I would like to work with, usually, but yeah. They were selling matchsticks, by the way. You can make big money by selling matchsticks, obviously. Yeah, and he was talking to people like that. Funny side note. Okay, so but we have this number. So obviously he had a number of all his employees, and if we do a sales table, we get this number, and this number should be our primary key. Okay. Okay, so we're already in the second normal form, which is not bad. Yeah. Now for the third normal form, yeah, so we have to do the first normal form. We identify the columns, we identify the obvious tables. Second normal form, we're identifying the
ID,
the primary keys in there.
primary key.
Yeah. primary keys and split them up. Also, what we do in the second normal form, I forgot that, is that we talk about what kind of relation we have between the different primary keys. So let's say salespeople have two addresses because they have their private address and they have their home address. And some of them only have a private address, but all of them have a private address, but some of them also have a office address. So how would you handle that?
One to many.
Sorry? One to many.
It's a relation one to many.
You could do it like that. And then what does that mean?
It means that our ID corresponds to more locations. For example, for more,
So yeah,
we have
but
an ID for locations. It means it corresponds for more IDs in location.
yeah, okay. So I guess what you mean here is that we're doing one table for addresses, and we're doing one table for persons, salespersons, and we add one to the other by getting the ID, the primary key of the salesperson, and add it to the address table at the corresponding address. So, and this is what we call a foreign key. Yeah. So the primary key of the sales guy in the address table is called a foreign key. That's the relation that we have between these tables. So, and obviously I can have like two lines in the address table that both have the same ID of a sales guy there. Yeah? Understood?
Yeah.
Everybody clear on that?
Yes.
Okay,
So we
now,
have
yeah?
so we have two tables for the locations and one for the customer. What?
No, we're
Yeah,
talking, at the moment, we're only talking salespeople. Salespeople and their addresses.
salespeople. Yeah,
So we
yeah.
have salespeople is one address, is one table, and address is one table. So we have two tables. So, and if now somebody has like two addresses, a private and a office address, then you have just two lines in the address table. And at
Oh
the
yeah,
end
yeah.
of the line, you add the ID of the sales guy that is to which this address belongs. So that's a
Okay,
one-to-many
so
relation we have here. Yeah, clear?
yeah, yes.
Okay.
So in the uh, address table, we can have, for example, one row where we have basically two IDs. I don't know how to explain this, but I understood it.
Yeah.
I
Okay.
think so.
Okay. Samuel, also clear?
Yes, from what I understood, we have the main table that has the sales guy, then another one for address, which contains address, whether home address or office address, as the case may be.
Mm-hmm.
Then we link those addresses to the salesperson that owns it with the ID of the salesperson. That means in the address table, you can actually have the ID of a salesperson up to 2 times, depending if he has two addresses.
Yeah, I'm going to show it to you. Just a moment. We're going to make our first example. If I find my mouse here. Yeah, there it is. So, are you seeing my screen? No. No. So come on. Mm-hmm. Why is this not working? Oh, I want to. Es wird nichts übertragen. So you're seeing now the screen from me? No?
Yes.
Oh, yes.
Yeah, the
We
one
see an empty
with the
one.
mountain.
Yeah.
Yeah.
Yes.
Yeah.
Okay. So now I got to find the mountain. Are you seeing the Excel here? No, not seeing the
Oh,
Excel at
dear
the moment.
mercy.
So, but now you're seeing an Excel file, right?
Yeah.
Mm-hmm.
Okay. So, and now I say this is my sales table, and I'm giving ID, first name, last name. Sorry. Yeah, and then we have like 1000 Tom Taylor and 2000 sorry 202,000 is maybe Samantha Smith, and 3000 might be Victor whatever. Yeah, so we make it wall trout whatever, so that we keep that. So, and then I'm going to create an address table, and we're going to zoom it in a little bit too. So, and we have like also an ID. Then we have a street number, zip city, zip city. Let's make it a country too. And then we have like one is one street, 123, and one city, Germany, of course. So, and there we have sales ID, and there we put the 1000. So that means that Tom Taylor lives at one street, one city, Germany. Yeah. So, and then I have a second address that is one street 234 at 12345, one city in Germany. And that is the office address of Mr. Taylor. Okay. So Tom Taylor has two addresses, both in the same street, in the same city, but at different street numbers. They're identified by their respective IDs, and these are attached by the sales ID to this person. So this ID here, yeah, you're seeing it, A2, this ID is corresponding to that ID here. Okay?
Mm-hmm.
And then we make a third, and that is Smith Street 555 in 44556. Smithsonian is the name of the in the USA maybe, and this is of the salesperson 2000. Yeah. So Samantha Smith lives in Smith Street in Smithsonian in the USA, and this is why this address is attached to her. And then we do a fourth address of wherever street in wherever in, okay, Romania. Sorry that I called the city in Romania wherever. Didn't mean to do that in the beginning. I wasn't thinking of that. So, and that's that. So now these, oh, sorry, these salespeople each have at least one address, and Tom has two addresses. Yeah? Okay. Is that clear to everybody, or do
Yeah.
Yeah.
yeah, okay. So what is missing here? I told you that each of them has at least a private address, but some have an office address too. I cannot determine at the moment which is the private address and which is
Private
the public
address.
address. So what do we need?
A column to specify private or public.
Exactly. I would say let's copy it, whatever. And can't I let, or is that, well, okay. We're doing it like that. And then we have like type, and that is private, that is office, that is private, and that is private. Okay?
Mm.
So like this, we can determine which address type is that. Okay? So basically, that's what we do. Now we see a very, very nice anomaly that we're going to get rid of in the third form. So at the moment, we're in the second form. We identified the primary keys, okay? And we identified the foreign keys. So this is the foreign key pointing to sales table and there to the ID column. Okay. So
Yeah.
I should have done it on the column up there, but okay, like this. Yeah. So this is our foreign key. This here is our primary key. Primary key for addresses. And you see, we created that one. There was no primary key like this. If we would have taken like, we could have said that the address is determined by street number, zip, and city and country. Yeah, that's the only determinator I have of a whole set. Yeah, only if I know all data, I know the data. Yeah, which data set it belongs to. So this is a case where I go and create a primary table on the fly. Yeah. Whereas here in the sales table, this is the primary key for the sales. Primary key sales coming from the sales. How do you say? From the ERP system. Let's talk like that. Yeah. So this is basically coming somewhere else from. So you're not creating it. You're getting this as an attribute, but with this attribute, employer ID is what I would call it there. And this is coming from whatever ERP system. Anytime you get a new employee into your company, he gets like this number, and this number is not like is given explicitly, and we get this as an attribute. So this is a primary key, because with that I can see which other data here belongs to. So maybe we have like a gender, so male, female, and maybe we have let's say, region they work in here. So South, no, he's in Germany, all of Germany, Southern USA, and Northern USA. Let's just go for that. Okay, so we might have other attributes, but if I know this attribute and I know which table it belongs to, then I can get, with this attribute, I can get all of the others. Okay, so that's a primary key. So this column here is the primary key column, whereas this here is a created primary key column that we just invented. Okay, maybe we should call it address ID. Address ID. Okay, so now we're at the second form. We determined the primary keys. we determined the foreign keys that were pointing to the other tables, okay? And we got to like the first point. So this already is a lot better of what we had before. This is a lot more structured. And now we come to the third form. And the third normal form, is determining if there is other relations in between the columns. So if one attribute induces another to have a certain value. So if I know this attribute of that data set, I know that this attribute has to be something else. Yeah? Or is there another relation in there? Yeah? Also, we can think about inserting, updating, deleting. What will that do? Yeah? So, for example, you're still seeing my Excel, I hope?
Now we do.
Sorry? You do?
Yes.
Now we do.
Yeah, okay. So, if, for example, I find that I need another type of address. Yeah. So we have private, we have office. Yeah. And we may be having, yeah, we have a second private home. Some people have two private homes, two homes. Yeah. One for the weekend and one for Monday to Friday. So, and I want to have it as secondary private. Yeah. How would I go about this? What would I do?
Secondary private.
Yeah. So because Waltraud has yet another street number and yet another, and that is maybe in Germany, and that's a private second, let's say. And this is also 3000. Yeah?
Then I'll do secondary private in the type.
Yeah. Okay. And now I come to the meaning that I have like, let's imagine I have like 10,000 people in here. Yeah. In that table, in that address table. Yeah. There's 10,000 addresses in there. Okay. And I see that I have to rename the type column because private second is shit. I want to have it as additional private. So, yeah, I want to rename here additional private. So if I have 10,000 lines or 2 million lines in here, yeah, you're laughing. Why are you laughing? This is what happens in real life.
Not if you extract it in another table.
Nice move. Yeah, but this is what happens in real life. I want to be able to rename the type. Yeah, exactly. So if you extract it into another table, then we would have another table, and we have like the type, which is its own kind of attribute in our own table. So we have an address type table, and there I have like address type ID. It's a little bit small. So address type ID, and we have a name, and this is like 1, 2, 3, and we have private, we have office, and we have additional private. Yeah. It could be like shipping address in a shop or something. Yeah. So, and then we go here, and there we do like 1, 2, 1, 1, and 3. Okay?
I didn't see what you did.
Yeah, it's a little delay.
Okay, I see. Now it's delaying before
Yeah.
showing.
You need to pay attention. That's it. No, of course. So tell me if there's a lag. So okay, so this is like we have these here, and that's like the primary key. And now we induce this here. Also, do we have another relation or another referencing in there where we have one table, one column is determining the value of another column in here?
The zip is determining the city or
Exactly.
something like that.
If I know the zip together with the country, I know what must be in the city field. You all got that? Within
Yeah.
Yeah.
Germany, the zip code determines which city it is. This is usually something, so that is a typical third normalization form error here. Yeah. So we have the zip code and the city in the same table, although the zip code determines what the city means. Yeah. At least within one country. The zip is determining the name of the city. And usually you want to get rid of that. I even encountered a use case for that scenario because mostly you do not find this. This is usually not what it's done here. Yeah. Usually you find zip and city in one table and not in an extra table. I had in the 90s, beginning of the 90s in Germany, we redefined all zip codes. Yeah. So every address was getting a new zip code. Before we had 4 digits, now we have 5. And they were completely breaking up everything. So this would, for a table where we have like 200,000 or 200 million of addresses in here, yeah, this would be a real pain in the ass. Okay? So because we would need to update all zip codes from a 4 number to a 5 number, and we would need to determine which city is to which zip code and so on. This can be done. This is not like a big problem for database people, if you ask them. But if they would have done the normalization first, yeah, then this would have been an easier task. Yeah, you could have just translated one into the other. Okay, understood? So this is the kind of
Yeah.
anomalies you need to take care of. Also, or you need to think about, what happens if I delete Tom Taylor here? Another thing we need to talk about. What shall happen to these two addresses? Should they be deleted or not? Yeah, they must be deleted. Otherwise, we have residues from another sales guy in there. Okay? So I need to have a logic, a trigger that when deletes, that when we delete this here, one line here, we need to look for the corresponding lines here and delete them too. Okay? Are you all with
Sorry,
me?
is it not if you delete on the table of the employee, then the address should be deleted?
Yes,
Or is it the other
exactly.
way around?
No, exactly. You're an employee. I can put you into my employee database even without an address. But then
Yeah.
you're giving me one address. I put in one address. Then I'm giving you, you're giving me another address. I put in the another, and I could put in the third address too. So I have 3 addresses for you. When I now delete you from the database, I need to delete all the addresses too.
Yes.
Exactly as you said.
Okay.
Otherwise, we're going to have a problem in the database because the table is going to grow and not to shrink even when we delete some salespeople. Okay?
Okay. Mm-hmm.
Okay. So now we're getting back to what you need to do. Come on.
What?
Yeah, because I prepared, if you remember, I prepared a. So you're seeing this new table here?
No.
Okay. But I'm making you see it very soon.
No, we have not seen it.
Yeah, okay. So I need to, where is that? Uh, uh, uh. So, but now go to the meeting in Outlook, and there is an Excel sheet attached to it. If you don't see it here, we're going to go that way.
We can see it now.
Ah,
We
okay,
can
very
see.
good. So I
We
have
can
like,
see it.
yeah, I have
We
like two.
can't.
You can or you cannot.
We
We
can.
can. We can.
Okay, so and that's why I said we have here one table with raw company data, and we have one table with raw CD collection. So I put
Mm-hmm.
in here data from my CD collection. Well, not mine actually, but doesn't matter. And I put in here some data from companies. I want you to pick one of these two sheets. Yeah, either you use the company data or you use the CD collection. And I want you to do the first three normal forms. Yeah. So you see, we have here some
Sure.
person address. They may or may not have the invoice address. You see, this was some sloppy guy that put that in here because this woman has the same data in here than there. Yeah. And these are the invoices separated by commas. Yeah. So somehow separated the invoice date with a description and a sum. Date, description, sum. Yeah. And we have this kind of data all in here and in there and in there. And you need to now determine what columns do we have, what tables do we have, and how are those tables going to have their primary and foreign keys. Okay?
Okay.
Yeah.
Same here for the CD collection. We have like CDs here, which is the group name or in musician name. This is the title of the CD after commas, and this is the genre. Yeah, even a misspelled genre here. Also, yeah, this here, that jazz pop, yeah, jazz pop. So the genre could be like different stuff, and then we have here all the titles on the CD. Yeah, thank God for Wikipedia where you can copy that stuff. So you have the title number, you have the name of the title, and you have like the length of the title. So all this data in here, I need you to do either this or that and structure the data into columns and tables and referencing them with foreign keys so that you get the same amount of data in all the tables without having too many update, insert, delete anomalies. Okay?
Just want to do, I hope.
Yeah, one of
Oh,
the
both
two. You
of them.
pick one or the other. This one is a little bit more
Very important.
complex. This one is a little bit more complex, and the other one is a little bit easier, but it's more data. And I want to see like the different data tables. You can do them in Excel. You can do them in MySQL, whatever you like. Yes.
Yeah, sounds good.
Okay. So, and last thing is, I want you to read up on the different relations, like we have one-to-one relation, one-to-many relation, and we have many-to-many relations. These are the three types of relations we have: one-to-one, one-to-many, and many-to-many. So I want to have solutions for all three types of relations between data sets. Okay? That's pretty easy if you do the exercises. You'll stumble upon them.
Yeah.
Next meeting tomorrow, so you only have tonight between 10 p.m. and midnight to do this.
What?
Yeah, what? Exactly. What is the exact thing? So, yeah. No sleep tonight. I want the exercise done tomorrow.
Sounds like a plan.
Sounds like a plan. Any questions so far?
I will not ask question.
Okay. No more questions. Get to work. Have fun, guys. I'm looking forward to
Thanks.
seeing you tomorrow.
Thank you.
Thank you.
Bye.
See you tomorrow.